My name is Alex Neuwirt. I'm the founder and president of Canary Systems. Today we're going to talk about AI, artificial intelligence. This material was originally presented at the Slope Stability and Mining workshop as part of the conference in Vancouver, Canada. That was October 27th through the 29th of October 2025. The workshop was actually on October 26th and was part of an educational program that was attached to the conference. The abstract for this discussion is Incorporation of Artificial Intelligence Learned Numerical Processing Algorithms to Improve Risk Management in Surface Mining Operations. I will say the presentation today will be more focused on just the integration of AI technologies, and we'll consider several use cases around this. We won't spend a lot of time on the numerical processing algorithms. Hopefully in upcoming presentations, we'll have the opportunity to present more of that. But we wanted to really discuss the topic of just integrating these technologies. There's so much in the media and so much reporting today about the impact of artificial intelligence. We wanted to share some of the interesting and useful ways that we've found to use these technologies in managing risk in mining operations. We have several discussion topics. We'll briefly talk about what is artificial intelligence. We'll look at the history, like how did we get here? We'll consider how it can help us manage risk in different environments, in this case, in mining operations. We'll look very importantly at some of the limitations around artificial intelligence, some models that we've developed for success. I'll have a demonstration video, and then last, a summary of some of the topics that we'll consider here today. First of all, what is artificial intelligence? It's defined as a field of computer science focused on creating systems that can perform tasks that typically require human intelligence. These tasks include learning from experience, understanding natural language, recognizing patterns, solving problems, and making decisions. I will say, I am not fond of the term artificial intelligence. The word intelligence is very associated with humans, and to suggest that computers can artificially recreate what is really an amazing capacity of humans, the intelligence that humans create, I believe is a little insulting to our abilities. It's insulting to human intelligence. Our brains are really an amazing tool for learning and for decision making, and the capabilities of our brain are really far beyond what computers can do. Even in today's state of advanced technology, what the computers are actually able to do is still far away from what our brains are actually able to do. One term that I've heard suggested, which I believe is a little bit more accurate, instead of calling it artificial intelligence, to describe it as child intelligence, because of the level of capacity that we see today. ChatGPT actually defines modern AI in two broad categories: narrow AI or weak AI, designed for specific tasks, playing chess, identifying objects, generating text. This is the type of AI that we have today. AI that, for example, can drive a car. This is really narrow AI, as opposed to the real goal or dream of computer science and artificial intelligence, or in general, to create general AI or strong AI. So this would describe or be more closely aligned to what our brains can actually do. So general intelligence, consciousness, our ability to understand, learn, and apply knowledge across any domain. It is theoretical and hasn't been achieved yet. Thank you, ChatGPT, for helping us understand that. You also see in the media a lot of confusion around these two types of AI. Part of it is some of the language that you see being used. And even in marketing and sales of companies that are promoting these technologies, they'll suggest that they have Gen AI, which is often confused as meaning general AI, but actually they're referring to generative AI, meaning the ability of narrow AI to generate certain types of content. For example, to generate images, to generate computer code, to generate words organized as papers or essays or explanations of different topics. So this is not general AI, it's simply generative AI, the ability of these tools to create material. How did we get here? Well, I did ask ChatGPT to create an illustration of the important milestones in the history of AI. We'll talk a little bit more about this illustration in a moment. Obviously, there's a lot of other key dates in the development of AI. These are some that I believe were really important in the development of these technologies. Of course, humans have been uh, theorizing and hypothesizing about machines that can mimic humans for hundreds of years, really, beginning with perhaps even some of the early computers like Babbage's calculating machines. 1950, though, is in my view one of the key early dates in the history of AI. Alan Turing at the time published a paper promoting what was called the Turing test. So, can a computer fool a human in conversation? He suggested at that time, when this is achieved, we will in fact achieve artificial intelligence. In 1956, the term was first proposed at a workshop at Dartmouth College. In 1958, predictions began being made about the the rate at which development or advancement would occur in this field of study. It was suggested that within a decade, in 1958, that we would have perhaps even general AI. Obviously, those predictions proved to be wildly optimistic. In 1966, interestingly, the first, what was actually early called Chatterbot, was created. That's since been reduced to chatbot. I actually prefer the term chatterbot because using the word chatter is, in my view, more suggestive of what these tools actually do. Meaning, chatter has a suggestion of not very consequential. And my view is today as well, most so-called chat that occurs is not very consequential. In any event, it was shortened to chatbot. This first chatterbot was named Eliza, and it was created as a psychological analysis tool, essentially a way to invite sharing of of person's experience. For example, how was their day? And what were some of the challenges that this person um, that faced in that day? Eliza was very simple in that it looked for certain keywords, responded to those prompts from the humans with essentially predetermined um, sentences, or really a script that gave the suggestion that it was paying attention to what the humans would input to the computer. There was a long period between 1966 and really to the 1990s where progress was very limited. Some suggest this was like the winter of the development of AI. Largely, this was due to limited access to computing resources. In the 50s and 60s and 70s, computers were confined to large mainframe computers, very limited access. Even if you did have access, the computing power was very, very low. Modern cell phones, for example, have hundreds of times the performance of any of these massive computers that were designed and built in the 50s, 60s, 70s, even the 80s. In the 2000s, the first real successes began to be seen because of significant advances in processing and data storage in particular. In 2012, the first compelling deep learning model was developed, coincidentally named the AlexNet, different Alex from myself. In 2015, AlphaGo defeated a top-ranked Go player. And then shortly thereafter, AlphaGo Zero learned the game on its own and beat AlphaGo. Go is considered a, a much more advanced analytical game, even compared to chess. So I didn't include the milestone that AI included in 1997 when Deep Blue beat one of the reigning chess champions of the world. This method that it used, though, was considered much simpler compared to what was developed to play and then ultimately beat the world's highest ranked Go players. What was interesting about AlphaGo Zero is that it was provided really very little direction on how to play the game. It actually figured out the game itself in a very short amount of time and then beat the world's reigning um, um, computer champion, which was AlphaGo. In 2017, a group of Google engineers published a paper on transformer architecture. And this was an attention-based neural networking algorithm. So in other words, um, not just relating information to each other based on subject, but also by attention, how much some information is more important to other information in the context of the questions that are being asked. And then very importantly, 2022, which was only 3 years ago now, ChatGPT was released. And this was based again on a neural network model with transformer architecture. And this was really a key date, most recent key date in the history of AI. Since then, of course, we've seen almost like an acceleration as these models have been incrementally improved from the original release of ChatGPT. It seems like from all the media attention that it was many years ago that we've had all these technologies with us for a long time, but really it was just about 3 years ago that the first widely available, really powerful and useful artificial intelligence tool using a large language model was released, and of course in the form of ChatGPT. So how can it help us to manage risk? This illustration hopefully helps explain what is now possible with the use of these technologies. These learning large language models, which are captured by ChatGPT and other tools in the marketplace now, like Claude and Grok, they absorb information learning from many different sources. And all of this information is now available to us. So you have general practices around risk management, soil mechanics, structural mechanics, general mechanics, material science, machine learning methods, statistical functions, rock mechanics, Python coding. Now imagine again your brain having access in just a matter of seconds to all of the learning around these different topics. And that's really what these tools bring to the user. The capacity to store and recall all of this information that's available is really way beyond the capabilities of the human brain. And yet now we easily have access to all of this learning in just a few questions that are asked of these agents. This is an important way that it helps us to manage risk, because when we're assessing our environments and when we're assessing the risks that we need to manage, we now have so much more available to us in terms of learning and processing of information than we had before. In other words, a human is limited in how much we can store in our brains. Now imagine having the entire body of learning around these different topics readily available for helping us to manage risk. It's important, though, to consider the limitations. The illustration that I shared earlier we'll talk a little bit about, and then the dialogue that I asked of ChatGPT around it. One of the first artifacts that computer scientists noticed is lack of comprehension around behavior. In other words, AlphaGo made moves that nobody observing really understood. And this has actually become much more obvious with complexity. In other words, the humans watching the outcomes or the choices that these tools will make are often not understood. At times, the answers that are provided can be just plain wrong. So notice in the illustration, ChatGPT suggested that ELIZA was created in 1958. I'm familiar with the history of AI. It's a subject that has been of interest to me for many years. So when I looked at this illustration, that date did not look right. I asked ELIZA, pardon my grammatical mistake in asking ChatGPT about the date when ELIZA was created. I asked ChatGPT, was ELIZA created in 1958? And notice the response back. No, ELIZA was created in 1966, not 1958. This is a really important limitation that you must be aware of when using these tools. They will often come up with the just plain wrong answer. Related to that, they're prone to hallucination, meaning you can ask it a question and it will respond in a way that's really quite unrelated to the question that you asked. You have very contextualized answers at times. So in other words, you can ask the same question, but depending on the questions that you had asked prior, you will get a different answer. The perception of intelligence can lead to ascribing human-like qualities to these tools. This was dubbed the ELIZA effect. So even back in 1966, they noticed this immediately. Humans started sharing with the computer information and feedback that was really unusually intimate. Now, keep in mind again that ELIZA was a very simple tool. It was essentially just a script. It was based on Rogerian psychology, but it was a very simple system of just responding with prompts based on a few keywords that it would identify. And yet, when humans were using this, they would often share intimate details with the computer that they had not even, in some cases, shared with other humans. So there was a connection made to this tool. A human-like quality was ascribed to the computer, but it wasn't really accurate in comparison to what this tool was actually doing. Another limitation is that there are many different models out there now. So these are the learning sets. So how did the model become trained? Well, depending on the material that was provided to the model, different results will be produced. It leads to a good question like, who decides what this learning actually is? The companies that are promoting and providing access to these different tools, they do not share exactly what materials were used in the learning. So we have to trust that the material they gave to their model is the most accurate for the types of inquiries and questions that we're trying to seek answers to. Related to that, there's human bias. Some of the early models were notoriously negative. Well, because it turns out so much of reporting and so much of the material that we have publicly available is of a negative nature. This, I believe, is just related to our human disposition. Humans, for better or worse, favor negative information, negative news. Likely this is a artifact of our primitive instinct, our primitive origins, where negative information was more likely to be helpful for survival than positive information. In other words, threats and fear around what could harm us historically may have been more useful to us than positive information. So you see that in the material that's available for training. You see that in the news. You see that in so much of what we read and are exposed to today, this negative bias. Well, if this is the type of material that's then fed to the models, then the tool itself will have a negative bias in answering questions. As a result of this, 3 out of 4 AI projects fail. And actually, since producing or since seeing this statistic, I've seen others that are even more negative. As much as 95 to 98% of AI projects fail, meaning the objectives that were outlined for the project ended up not being met. So in other words, I would say the problem is not so much the tools, but that we expected more of the tool than could actually be reasonably provided. And you see that in the media today. There's so much hype about these tools. Look at just the valuations of companies. Anthropic, which produces the popular Claude tool, the valuation of Anthropic just this year in about a 6-month span went from 60 billion to something like 180 billion. Other firms like Palantir or OpenAI also have very similar kind of crazy valuations based on hype around what these technologies are thought to be able to provide to us. At the conference, I had a attendee follow up with a great question or suggest a great question in the after workshop discussion. The attendee suggested that I ask ChatGPT a follow-up question to explore how it produced the wrong answer. So I did. I went back to ChatGPT. I went back to the chat that I had already established with ChatGPT for this illustration around the history of AI. And I asked ChatGPT, why did you believe ELIZA was created in 1958? And interestingly, ChatGPT basically came up with a dog ate my homework excuse by saying, in short, it wasn't deliberate. It was an inference mix-up between the invention of Lisp, which was an early computer programming language, and the creation of ELIZA. But think about it. ChatGPT just completely mixed up 2 very different ideas, and it produced an illustration which had the wrong date for the creation of this tool, ELIZA. Let's look at some models for success. We're going to talk about 4 different models. 3 will demonstrate in a video that I'll share shortly. One of the realizations then, in consideration of these limitations, is that you have to be really careful what these agents, these AI agents, are allowed to do in an unattended fashion. In fact, what we've found is that the AI agents are really great to create forms of output, but not to be used directly to work with when it comes to data and to risk management. So these illustrations will hopefully explain what we have been able to find to be very effective. The first, AI-assisted database search. The illustration to the right just shows how we implemented this. So through a search query that we send to the AI agent we trained on our database schemas. And so the AI agent did not search through our databases directly. No, what it did was based on the search query, it created a SQL statement. SQL is the programming language behind our databases. So it created a SQL statement that was then run against the database to then retrieve the results of that search. So instead of allowing the AI agent or requiring the AI agent to learn all of the data and all of the content in our database, by just training it on the schema or the structure of the database, it very quickly was able to create code that was then used to run and produce the output. So hopefully you understand the usefulness of this. Instead of the agent running around in our databases and producing who knows what for responses, it produced this code, this SQL, which we could validate and verify was correct code for the types of searches that were being requested in our databases. AI-assisted data elements and data selection. So similarly, the AI agent was again used to create a SQL query to return the results of a search for particular data elements or elements that are capturing data and criteria around that data itself. It created the SQL code, and then that SQL code could be then used to send data to, for example, our charting engine, Plotly. A third use case, AI-assisted configurations. We use a charting tool that has a published set of documentation called Plotly. So by training the AI agent in how Plotly manages chart configurations and feeding the AI agent the data and the chart configuration, now configurations of the chart can be very easily updated. So typically the chart configurations require knowledge of an extensive inventory of options around the style of the chart, the series configuration. But once the AI agent understands like how this charting tool manages all these configurations, it can very quickly update these chart configurations with those natural language queries. And again, I'll show you an illustration of that in the video I'll play. And then last, AI-assisted data analysis. The AI agents have an immense body of learning and knowledge around how to interpret data that we're collecting as part of the risk management process in different markets, mining in particular. So by using the AI agent to create these analysis and in the form of Python code, we can then feed the data now to the Python code and then create these HTML reports, which are created from the Python code, which was created by the AI agent. So again, the AI agent is not directly interpreting or analyzing data. Rather, it's creating code. So we're capturing that processing, that analytics in a standard form, which then can be fed data to then create our risk assessments based on the code that was created by the AI agent. Let's illustrate some of these different methods. So I've got a video to play. This was originally a 30-minute video. We sped it up to about 10 minutes. So you'll see as I'm playing this, the screen will flash on occasion. So what's happening in the background is there's a data import process running. There's a screen refresh. So you'll see that kind of blinking effect, but that's largely just because of the speeding up of the video. So let's get this started. And as it's playing, again, it's about a 10-minute video. I'll speak to to what's actually happening as part of this demo. So on the left, we have a chart. On the right is the report, the HTML report, which again was created by Python. This Python code was created by the AI agent. So this entire report was actually created from a very simple query to the AI agent. So it looked at industry best practices around this type of data. So these are piezometers being monitoring elevations in a mining operation, water elevations in a mining operation. You'll see we scrolled through the report that's being made. So in this dashboard, we've got these two panels, chart on the left, output on the right. Now, we open up the charting panel and we ask the AI agent to filter the elements list by a certain class in the database. So you see that happening in our AI elements query, goes into the database, finds the elements that match that class, and then updates the chart. That chart of data is then linked to this report. And so the report automatically updates once that elements list is updated to match. So again, this is the kind of model that these are the kinds of models that we found to be very effective to use the AI agents to use all of its learning and understanding around risk management to create these kinds of outputs, again, in the form of Python code, and then just integrate that Python code, in this case, through linking the HTML report output into the dashboard window. So as data updates in the database, as the chart updates with that filtered list of elements, this report automatically updates. And you can see several elements to this report include a evaluation of the frequency of data, an evaluation of thresholds of the data, an evaluation of velocities of the data, and then some just general assessments about whether there's any areas of concern. You can see at the top of the report there's an alert being generated. Now let's look at the AI elements query and update it to look for elements in the database that are above a certain threshold. So again, the AI agent is creating SQL, which then retrieves this list of elements based on a threshold value. So very quickly, you can find data of interest in the database. The threshold in this case is an arbitrary value, but typically it would be based on the threshold values that were defined as part of the TARP assessment. So pardon these the values that are being used, but for illustrative purposes, we want to show just how the tool can very quickly find data of interest. So this database, just keep in mind, has hundreds of different instruments in it with millions of data points, but very quickly using this AI agent model, you can see data can be found of interest much more rapidly than if you were to be scanning a series of charts or looking at the data itself. Simply by asking it to evaluate data based on a certain threshold, very quickly returns that data of interest. You'll notice in that demo, like the initial value was 180. That produced a fairly large inventory of elements. Then by increasing that threshold to 183, you'll notice now just two elements met that criteria. And then the chart updates, and as new data comes in that meets that threshold value, the chart updates with that data. I'll speed up the chart a little bit for sake of time. I'll advance to about the 7-minute mark just to show you uh, some of the other use cases for how we integrated AI technology. And again, this report was entirely created by the AI agents. So those assessments, the tables of data, and it was based on a series of queries around how typically this type of data is represented in this environment. So going back to my earlier slides about what the AI tool then gives you access to, not just generalized methods around presenting data, but methods that are specific to the industry and to the environment that you're trying to manage the risks in. So the query's updated to capture more instruments. All right, let's advance to about the 9-minute mark. One of the use cases had to do with chart configuration. So you notice earlier we had asked the AI chart editor to add a threshold line at a certain level. Now we've asked it to add a background. So again, normally this would require wading into the intricate configuration panels for the chart, but now we can just ask it to create a more visually appealing background. And notice what the AI agent did. It went and updated to a darker background so that the series traces are just more obvious in the presentation. And then last, we're showing the printed or PDF version of this report that the AI agent created by the running of this Python code. So again, this is not a static panel, but it also can be used for sharing of these critical monitoring alerts by exporting this into a printable or distributable format, such as a PDF. In summary, how does incorporation of AI improve risk management and surface mining applications? It improves our efficiency, so our ability to find data of interest just accelerated by orders of magnitude. You'll notice in that demo video, we were able to filter by thresholds, really any type of criteria that we can imagine, thresholds, rates of change, correlations. We can very quickly find data that meets those criteria. Your brain got a lot bigger. The tools are incorporating essentially the entire realm of knowledge around data processing, around best practices in different markets, the use of Python, for example, also now provides you access to hundreds of modules, thousands of modules really around numerical processing of data, related to that, not just Python, but just the power of programming in general, whether it's SQL, whether it's Python, whether it's C Sharp. These tools are really good at writing code. And again, the advantage with using the tools to write code is that you capture a way of working with data that will be repeatable and not subject to some of the limitations of these AI agents, such as hallucination or incorrect contextual answers. The question is the answer. One of the realizations when you use these tools is that you will be pushed to improve the questions that you ask. And so the question becomes really critical to getting the right answer. And these tools have a very consistent approach to answering questions. Yes, they can be prone to hallucination on the wrong answers, but again, that process forces you to rethink how you work with the tool, how you understand what you're trying to achieve, and the kinds of questions that you need to ask to get the best answer. Context is everything. So you're forced to think about the context that you're working in. So in other words, thinking about environmental factors in the context of risk management. So what else should you be thinking about to get the right answer? So what's the context of the environment that you're trying to produce analytics around? It becomes very easy to expand your learning. These tools have already done so much learning for you. They've incorporated so much knowledge around data, around these environments, around risk management. So we can also then learn very quickly by using these tools. The models are improving rapidly. So it seems like every other week there's a new or next generation model that we can use for our applications. So we're seeing much better results. We're not anywhere near general AI, but we're seeing much better results very rapidly in the tools that are being released in the marketplace. And then last, more engagement. Our ability to work with data and to understand what's happening, to assess risks more critically, just accelerated by orders of magnitude, really. And so the tools really make that process so much more interesting, so much more efficient. And in the context of risk management, the more engagement we have, the better we're going to be able to manage our risk, and the better we'll improve the health and safety and the reliability of our operations. Thank you. That concludes our presentation of our experience with AI tools and technologies, and also some models that we found to be really useful in integrating these technologies to our markets and to the field of risk management in mining. Thank you.